How can neural networks learn useful structure from images and spectra? Today is day 25 of learning computational astrophysics, and I continued with deep learning. I started by using PyTorch and TensorFlow, which handle most of the computation used in training neural networks. This includes automatically calculating the gradients for backpropagation. I first used a neural network to estimate photometric redshifts from SDSS galaxy colors. So from just a few observed properties of the galaxy, the network learns to predict the redshift. I then moved on to convolution neural networks, or CNNs. For images, nearby pixels contain related information, so CNNs use small filters to move across the image to find useful features. These can include like shapes and edges. Pooling can then reduce the size of the data while keeping most of the important information. I trained one of these networks on images of clothing and reached a validation accuracy of 86% just after one epoch. Then I looked at autoencoders. You can think of this a little bit like a nonlinear version of PCA, where PCA compresses its data down to a few principal components, while an autoencoder learns its own compressed representation by forcing the data through a small bottleneck and then trying to reconstruct the original input. Variational autoencoders take this a little bit further. Instead of mapping each object to one exact point in that compressed space like PCA would, they map it to a probability distribution around that point. This creates a smoother latent space where nearby positions produce similar outputs. But that was day 25, see you next time!